Welcome to Plutus IS. Today we will discuss about the number of subgroups of the residue classes modulo M with the addition operation. So first we will see uh, which group we are talking about. That means that is called the residue classes. Residue classes with the addition. So we know that this is a abelian group. So this is an abelian group with the addition in residue classes. For example, Z6. Z6. What are the elements of Z6? We know about it. Elements of Z6 are these are the classes 2, 3, 4, and up to 5. In general, in ZM, how many elements are M elements, which are the 0, 1 bar, 2 bar, up to M minus 1 bar, and these are the classes and call the residue classes modulo M. In this case, residue classes modulo 6. We know about it. This is a group, an abelian group, an abelian group. We have to find the number of subgroup in ZM. So number of subgroups in ZM plus. So how to find? So number of which are the subgroups in the ZM? So we decide. We know that the result that means subgroups of ZM is determined by the divisor of M. So that means number of subgroups. So that result is the number of subgroups. Number of subgroups in ZM equal to number of positive divisors. Number of positive divisors of M. Okay. So for example, in Z6, for example, number of subgroups in Z6 equal to how many positive divisors of 6. So positive divisors of 6 are 1, 2, 3, and 6. There are 4. So 4. As the number of divisors of positive divisors of 6 are 1, 2, 3, and 6. So what are the divisors of 6 are 1, 2, 3, and 6 are the divisors. But okay, fine. If number is very big, like the 100,000, maybe 50,000, whatever, then how to calculate the number of subgroups? Or you can also say that how to find the number of positive divisors of number. Then we can decide the number of subgroups in ZM. So that is determined by the divisor function by using the divisor function. What is the divisor function? Tau is n to n is a divisor function. Divisor function. Call the divisor function tau from n to n. The number of divisors of n, tau n equal to number of positive divisors. Positive divisors of n. And how to calculate it? So if n equal to is the formula. If n equal to, we can write the every number in prime factorization. So p1 to the power, suppose n1 dot p2 to the power n2 and so on, pr to the power nr. Okay, where p1, p2, pr are the primes, are the prime numbers. Then tau n equal to, just write the this one as the alpha 1, much better. Write the, you can write the, if n equal to p1 to the power alpha 1, p2 to the power alpha 2, and so on, pr to the power alpha r is the product. So tau n equal to alpha 1 plus 1, alpha 2 plus 1, and so on, alpha r plus 1. So this is the number of positive divisors of n. So we can calculate the number of positive divisors of n by using the divisor function. So we'll see here, like in case of z6, we can calculate the number of subgroups in z6 equal to number of positive divisors, we can calculate the tau 6, and we can write tau 2 to the power 1 and 3 to the power 1 equal to 2. That means 2 is a prime to the power 1, 3 is also a prime to the power 1. That means 1 plus 1 and 1 plus 1. You can see that we are getting the same 4. So number of positive divisors of 6 are 4, and therefore the number of subgroups in Z6 is the 4. So now if, like the suppose, if you want to calculate the number of subgroups, in, like you have to calculate the Z100, then okay, take the big number like that, take the Z200. I have to calculate the number of subgroups in Z200. To simply calculate, how to calculate, to simply calculate the tau 200. So 200 can be written as 2, just take the factor of 200. So 2 into 2 into 4, 2 into 2 into 4 into 5, 20 into 500 into 2. So can we write the 2 to the power 1, 2, 3 and into 5 to the power 2. Then 2, 2, 2, 8 and 5, 5, 25, 25 into 8 equal to 200. So we can write the 200 in the prime factorization as this, and that is the p1 to the power alpha 1 into p2 to the power alpha 2. Therefore, number of positive divisors of 200 equal to simply alpha 1 plus 1, alpha 2 plus 1 equal to 3 plus 1 and 2 plus 1 equal to 4 and 2 and 3. That means 4 and 3, 12. So number of positive divisors of 200, you can calculate the 12, and therefore the number of subgroups in Z200 equal to 12. So by using the divisor function, we can easily calculate the number of subgroups of whatever the value given. So suppose you have given the Z, whatever the, suppose given as the 1000 or whatever given. So we can calculate the number of subgroups in Z1000 plus by using the divisor function. So simply we are concluding it, that means number of subgroups in Zm equal to number of positive divisors of m. And how to calculate the number of positive divisors of m? By using the divisor function, we can calculate the number of positive divisors of m, and that is equal to the number of subgroups of residue classes modulo m with the operation addition of residue classes modulo m. So also we can write That means actually subgroup in so subgroups of ZM is determined by the divisor of M. And how to write the subgroups of ZM we will see in the upcoming videos. Thank you.